Hello everybody and welcome back to another video in our Android Starter course. So in this video we're going to be continuing on with this book tracker app that we created in the previous video. And we are going to, in the previous video, you see we have this list of all of our books here and they have a check mark. But if I click on that check mark, nothing happens. Well, that's not exactly what we want. We want this to toggle between checked and unchecked every time I click on it. So to do that, we need to add something called state, because this UI, our app needs to have a way to determine whether this check mark is meant to be set or not set, rather than just setting all of them. So what we're going to do, eventually in this video, we're going to be using a view model to track our state. And a view model is one of the most important libraries that comes with Jetpack, and it allows different classes and different components of our activity to share data without having to pass them back and forth. So this is going to be used to manage the state of the app. And when I say state, I mean anything that needs to be displayed on the screen that's not hard-coded in. For example, here, right now, it is hard-coded in just to a checkbox. But in the future, when we're done with this, actually by the end of this video, that checkbox is going to be toggling back and forth. So that is going to be considered state, whether that's checked or not. Now you can save the state directly in the UI, which is something that we're going to start with, and I'm going to show you why that's not as good as putting it in the view model, and in fact that can lead to errors. And definitely one of those reasons is because you don't want your UI to have to do too much stuff. We generally like to separate out all of our different responsibilities and give them to different components. So our UI, we want to manage the UI, the user interface. We want that to manage only the user interface, and then we're going to use our view model to manage the state for that. Another reason is you don't want to put too much code within your UI, especially when if you have some code that you're using for like a network call, and then some code that you're using for a database call, and then other code that you're using for formatting or business logic. Well, this is going to make it very difficult to debug or maintain if we ever go back to change anything. And now, if we're looking to change something in the UI, we have to sort through all of this other code as well. Plus, you run into an issue where if in your UI you're doing network or database calls, and with those two calls, you're required to use a coroutine, which is an async operation. If you start an async operation and then you have maybe like a configuration change, like we rotate our screen, well, now that activity has been destroyed and recreated. And when that happens, now you have this async operation that wasn't destroyed with the activity and it has nowhere to return to. And this is called a memory leak. So this is what we want to avoid. And one way that we can avoid that is by putting those calls within the view model itself, because when the view model is destroyed, it's going to call its onCleared method that it comes with, which will clean up any currently running async operations that we have out there. What we're going to do first is come into our book tracker module, right click, do new Kotlin class or file, and we're going to call this our book tracker view model. Make that a class and then add that to Git if you have your project on Git. Class book tracker view model. So in here, we are going to need to make this book tracker view model inherit from our top level view model class that comes with Jetpack. Go ahead and import that. And then as for right now, one thing I'm going to do is I'm going to make a function and I'm going to call it getBooks. And I am just going to set that equal to our mock book list that we created over in our book screen. Now that we have our view model set up, we need to come over to our build.gradle file for the module app level. Go down to the bottom under the dependencies section, and we need to add a few lines here for our view model. Essentially, view model, we can already write it into the code and use it, but compose has a dedicated syntax that we're going to need to use. So because of that, we need to add a few things. So debug implementation, Android x.compose.ui colon UI dash tooling. And what we're going to do, you could do 1.4.0, but just to make it consistent with everything else, I'm going to do compose UI version, which is of course right now 1.4.0. And then beneath that, we need to add another implementation line, Android x.lifecycle. And then this top one here, lifecycle ViewModel compose 2.6.1. We need to add that as well. Go ahead and sync your Gradle files. And once your Gradle files are synced up with these changes in there, go ahead and switch back over to your book screen. And now in the book screen, we are going to actually add our view model into here. So right at the top level at this top composable function, we're going to add a val, we're going to call it view model. And this will be a book tracker view model, which is just equal to view model. And this will instantiate our view model class for us. Make sure to import that. And then after that, within our lazy column, down here on our items call, instead of saying mock book list, which is going to tie this to data stored essentially in our mock book list down below, instead of that, we are going to tie this to our view model dot get books function. And technically, because our view model dot get books function is still tied to our data down below down here, it's not fully decoupled. But in reality, this composable doesn't know or care where view model is going to get this data from. So I could come into my view model and I could change this function to be whatever I want it to be and to return whatever data I want. And as long as it's of type list of book objects, then my UI is going to be able to process that. So we have, in fact, decoupled the UI directly from this book item by tying it to the function in the view model that is going to be returning that list for us. When I say that we've decoupled this from our UI, what I mean is essentially this view model dot get books function could be getting data from a database somewhere. It could be getting data from a network call or an HTTP call. It could be getting data just from a hard-coded list like we have right now. And it doesn't matter. Our UI doesn't know where that data is coming from, and it doesn't care where that data is coming from, because the main concern of our UI is user interface. It doesn't care about where the data comes from. That's a job for the view model to handle. So that's what I mean when I say that we've decoupled our UI. So this view model function is going to be pulling from the view model store owner, which, because we haven't added any navigation to this project, in this case, the view model store owner is in fact going to be our main activity. So the view model's lifecycle is going to match the lifecycle of main activity. Now, this leads us into talking about state. So essentially, any data that we need to display on our UI at any point in time that we're not hard coding in, well, this is going to be considered state. So any data that we're changing that needs to go into the composables. Now, let's say we wanted to make a new composable, and we'll have a text field that you want the user to be able to update. So I have a new composable function here, and we're just going to call this text input. Now, within my new text input composable function, I'm going to have a text input state, and that is going to be a mutable state. So mutable state of type string. And mutable just means it can change. So a mutable state is a state that can be changed over time. Import that, and that is going to be equal to remember mutable state of, and then an empty string. Import all of those, and then after that, what we're going to need to do is add our actual text field and import that as well. And here we have a value. We're going to set that value equal to text text input state dot value, and then on value changed, we are going to need to set equal to. We're going to take our new value from that, and that new value is going to be set equal to text input state dot value. So we're going to dump our new value into our text input state dot value. And then after that, we have to add a label to that as well. And our label is just going to be equal to text input. So essentially, what I've done here is we created a state variable up here, text input state, to hold and remember the mutable state of a string variable. And then we've assigned that string variable to the value field on our text box. So what this does, putting it inside the remember block, means we're going to remember the value of this across recompositions of this. So even when this composable is recomposed, this value is not going to reset back to this empty string every time. It's going to remember what it was. And then we set this on value change, and we take the new value from that and we dump it back into the value of our state variable, which means anytime we change the value, we are now going to update the value that's being displayed to the user as well. So without this callback function, this text field actually wouldn't ever change even when the user was typing. So now that I've showed you all of that, let's go ahead and delete that function and see what we can do to apply this actually to our book tracker app. So in book icon, actually, let's go ahead and rename that. I don't like book icon. Let's do finished icon. So now in our finished icon composable function down here, let's get rid of this icon that we're passing in for now. We'll keep the modifier. And then this image vector here, instead of doing it like that, I'm going to make a state variable for that. So I'm going to say val read state equals remember mutable state of false, which is the Boolean value false. And then we're going to do val icon equals if read state dot value icons dot default dot check, which is going to give us that checkbox there if this is set to true, else icons dot default dot clear. So now down here, go ahead and import that clear icon as well. And actually our modifier down here, let's set that equal to the modifier that we're passing in so that we're actually using that parameter. And then we're going to make this leave the padding, but also we're going to add a clickable to that as well. So clickable lambda, we're going to do read state dot value equals not read state dot value, which means anytime that we click on this icon or this image, it's going to toggle our value of read state from false to true to false to true to false to true, which is then going to update our icon value and recompose our image here. So if I take this and I run it on my app now, oh, actually, it's not going to work because I renamed that function. So if I change this and rename it to finished icon, and we are no longer passing in an icon to that. We only need to pass in the modifier. So let's get rid of that. Now run it on my phone app. So this is what we want actually. If I say I take a book like The Return of the King and I click on the X, it changes to a check mark. And if I click it again, it changes back. So that's the behavior that we want. The problem is now, if I scroll and then scroll back up, everything I had selected is gone. So if I select a few and scroll down, so they're off the screen now, and come back up, then they're gone. So if you'll remember last time I told you this lazy column that we're using, this one, the lazy column, is only going to render everything that's needed for display on the screen right now within this column, meaning everything that's off the screen is going to actually be recreated when I come back to it. So if I leave and come back, it's going to be recreated. And when it's recreated, this state is going to be reset to false every single time. So it's not going to remember my checkboxes if I scroll away and scroll back. And the reason is because we've created finished icon as a stateful composable. And what that means is its state is stored within itself. It's aware of its own state. And because we put it in a lazy column, it's going to be essentially recreated every time we put that finished icon off screen. So there's a fix for that, and we'll get to that in just 1 second. But before we get to that, I'll also mention that when you're working with state, instead of using the equal sign, if you use the by keyword instead, you don't have to use this dot value. So a lot of people like to do that instead, and you'll see it like that. And oh yeah, also if you use the by keyword, make it a var instead of a val. So up here, make sure that's a var so that you can change it. And now if we run that code, we'll get the same exact behavior. So we haven't fixed anything. Essentially, we need to take this composable and make it a stateless composable, meaning the state is going to be stored above it. We're going to do something here called state hoisting. And what that means essentially is I'm going to take this state and I'm going to move it from finished icon to the parent composable, which in this case is going to be book item. And then after that, we'll see how it goes. And then after that, we'll move it from book item all the way up to book screen and finally into the view model. And I'll show you how the behavior changes each time. And essentially what state hoisting is going to allow us to do is it's going to allow us to make this composable stateless so that it doesn't have to manage its own state. And that's definitely, it follows a principle known as single source of truth, which is we want all of our data to be coming from one single point. In this case, it's going to be the view model or wherever the view model is getting that data. As far as the UI knows, it's going to be the view model. So we don't need to have all of these, all of the state saved within the UI itself. That's really not a good idea. It's much better to put it eventually into the view model. But for now, we're just going to take it out of our finished icon composable and see how that changes things. So first, we're going to need an icon, our icon parameter back in here. So we're going to pass an image vector into here, and then I'm going to cut this code out. And clickable, I'm going to change just to on click. And up here, we're going to have an image vector parameter, a modifier parameter, and then also I'm going to pass in this on click parameter, and that is going to be just a function of type unit. And now this function is totally stateless. But we have a problem, and that's the calling function that doesn't match the parameters now. So we're going to need to fix that. First things first, above this card, let's go ahead and put those state variables that we had. And now that we have those state variables, we need to actually come in here to where we're calling our finished icon composable. And we need to add the icon. And then also we have to add a lambda function to the end of this to handle our toggling. So that lambda function, we're going to do read state equals not read state. Now if we run our program, we have hoisted this state, down out of our finished icon up into our book item composable. But you could see we have the same exact problem, and that's because this icon is of course contained within our book item composable. So to fix this problem, we are going to actually need to hoist this all the way up to our book screen composable. And one way that, well, before I even do that, let's go ahead and add a finished variable to our book data type. So down here, our data class for book, I'm going to add one more parameter here, val finished, meaning is the book finished? Have I read it yet? And that's going to be a Boolean, and we are going to set that with a default value to false. Since we still have that same behavior going on, let's keep hoisting that state up. So what we're going to do here is we have our book parameter. We're going to add one more parameter here. On click, and on click is going to be, we're going to have an ID that we're passing in for the ID of our item in the list. And then that's just going to return a Kotlin unit. Now, put a comma after book. Now this on click, we're actually going to replace down here this lambda function that we created. Oh, where is it? Down here, read state equals not read state. We are going to replace that with our new on click function that we're passing in. So on click, and then we're going to pass it book ID. Now up here, this read state, again, I'm going to pull that out. And this icon, instead of read state, we're going to do book.finished. And now this composable as well is stateless, but once again, we need to deal with the calling function, the parent function here, which is going to be our book screen, because now we're calling these book items and we're not passing an on-click listener to it. The first thing we need to do is go ahead and add the variable for the state here. So val state equals is a mutable state of type list of type book, and we're going to set that equal to remember mutable state of, and then I'm going to do viewModel dot get books. So now down here on my items list, instead of saying viewModel.getBooks, all I'm going to do is pass it my state.value. And within here, we are going to need to update this one as well. So our book item now takes different parameters. So for our, well, actually, we're going to leave this as book item book, and then we're going to add a trailing lambda function to this for the ID of each book in our list. So in here, we're going to say val books equals state dot value dot to mutable list, and that's going to convert this books list into a mutable list. We're going to say val book index equals books dot index of index of first, and then in there it dot id, that is the ID of the first, we're gonna set that equal to our current ID, and then val book equals books, and we're gonna use that book index variable that we just created, and after that we're gonna do books book index. So the book at the book index, which is the first index of our list, we're going to do book.copy. And here we're going to say finished equals not book.finished. So when you're dealing with state and you use the .copy, this is essentially, it's going to copy every field in our book data type, and then whatever parameters you're going to have, it's going to set those parameters as well. So in this case, our book data type has an ID, a title, an author, and then a finished state. So if I do the .copy on that, it'll copy ID, it'll copy title, it'll copy author, And then because I'm passing finished as a parameter to that function, here you can see I'm passing it as a parameter. It's not just going to copy finished. It's going to use that new value for finished, which is going to be the inverse of that we're passing into that. And then after that, all I need to do is change my state value to my new books list that I have here. So now if I run this program, this is actually going to fix our problem. So if I click a couple of these and then scroll down and scroll back up, you can see they're still selected. And that's because the composable that we're saving this state in is no longer the book item down here, which is containing each individual card. Rather, it's the book screen, which is containing the entire lazy column. So this entire composable would have to be destroyed to lose that book. So this is actually going to work, and this is pretty much everything that we want in our application right now. At least for this video, we can have a list of books and we can check off the ones that we've marked, and it's going to go ahead and save those even when I scroll down away from that and scroll back. So that's the behavior that we want. However, there's still one issue here. If I were to take my phone and, so I have a couple of these selected, if I take my phone and rotate it, you could see now I've lost all of my state again. And that's because when you rotate your phone, your entire activity is recreated, and that state that was essentially this book screen composable also gets recomposed. So we have it working. In general, we have it working where if we just open the app and scroll it down and go back, it's there, but it's not surviving major configuration changes such as a screen rotation. So we need to fix that. And to do that, what we're going to do is we're actually going to hoist this state one more time out of book screen and into the view model itself. And that will also help us to follow best practices, which is separation of concerns, meaning each piece of the module is only going to be dealing with one thing. So this right here, managing the state of what's checked and what's not checked on our book list, that's business logic for our app. So that should be in our view model, not our UI, because our UI should be doing user interface things. And then it'll also help us with a single source of truth, because what we don't want is now we have a list in our view model that's coming back from this get books function. We have a list of data, and that has one set of true and false values for that finished variable that we added to our book data type or our book data class. And then within our UI, we have another set of what's true and what's false. And that's why it's not surviving a book rotation, or a screen rotation rather. When I rotate my screen, what it does is it recreates that from my view model. So this state I need to save within my view model instead of within my composable itself. We're going to make this composable stateless as well. So let's go ahead and do that. So from the book items function, let's go ahead and grab all of that code from that, not the function rather, but the trailing lambda block. Let's grab all of that code, head on over to the view model, and get rid of this get books function. Now in here, we can finally add our state. So val state equals mutable state of, and then our mock book list. And then beneath that, we're going to have one function, and I'm just going to call this toggle finished for toggling that finished parameter in our data class. So fun toggle finished, and that's going to take the ID of our book. So ID, and then within here, just simply paste all of that code that we copied, and now our view model should be good and ready to go. Let's go back into our book screen and update that. So the first things first, this state we're now storing in the view model itself. We don't need that at all. And then within items, we don't need state.value anymore. What we actually need is view model.state.value. And then within this block down here, book item book, and then within our trailing lambda block, all we're going to do is do ViewModel dot toggle finished and pass it our ID from that function. So now if I run this, you can see I can mark a couple, and it's going to survive me scrolling and scrolling back. So that's good. And if I rotate this, you can see it also survived screen rotation. So this is good. This is finally what we want. It's surviving both scrolling and major configuration changes as well, such as screen rotations. And we've decoupled our state from our UI. So now our state is over being tracked and managed by our view model. And our UI is simply free to manage the user interface, which is exactly what it's supposed to be doing anyway. And this is going to follow separation of concerns because our UI is now managing the user interface, and the view model is now going to be managing our business logic and all of our data for this class. And it's also following the single source of truth practice, because now our single source of truth for our book list is the book list within the view model. We don't have, like we had before, we don't have one book list within the view model and then another book list that's being modified and not sent back to the view model within the UI itself. So hopefully you found this video helpful. If you did, like and subscribe to our channel, and we will see you in the next video.